So I'm going to go over a couple extra problems practicing distributive property because I know not every student felt really comfortable with it the first time we did it. So I'm going to start with number 1. Distributive property is showing two expressions that look different but basically give us the same answer. So if we had 6 times the sum of 5 and 3 inside parentheses. So if I solved this just the way that it is, I know I would solve the parentheses first. 5 plus 3 is 8, and then I would multiply that by the 6, and 6 times 8 equals 48. Now distributive property distributes the factor that's on the outside into each addend on the inside. So if I take that 6 and I multiply it by the 5, 6 times 5 is 30. And then if I took that 6 and I multiplied it by the other addend, 6 times 3 is 18. Now if I add, because my operation inside the parentheses was addition, if I add 30 plus 18, I still get 48. So 48 is the answer both ways. So now let's try another one. Number 2. If I practiced with 5 times the sum of 9 and 5. So again, I can solve it this way, the original way. I can add 9 plus 5 is 14, and then I multiply by the factor on the outside, 5 times 14. I can bring it over here to the side and set it up with the standard algorithm and solve it the regular way. 5 times 4 is 20. Regroup my 2. 5 times 1 is 5, plus 2 more is 7. So this answer is 70. But what if I was asked to distribute that factor into each addend? So you can do 5 times 9 is 45. And then you can do 5 times 5 is 25. When I add 45 and 25, 4, 5, 6, 7, my answer is still 70. So both of those ways give you the same answer. One more example, number 3, is 2 times the sum of 9 and 2. So I can solve this the same way and do the parentheses first because of order of operations. 9 plus 2 is 11 times 2. 11 times 2 is 22. But if I'm asked to use distributive property, I can distribute that 2. 2 times 9 is 18, plus 2 times 2 is 4. 18 plus 4 is 22. So both of those answers give it the same way. I think what students were finding a little bit confusing was doing it the opposite direction. So if I come back up here and I grab my 30 plus 18, so 30 and 18, in order to rewrite it this original way with the parentheses, what I would need to do is find the factor that I can pull out of 30 and 18. So you can do it with any factor, but it's best to do it with the greatest common factor. And a shortcut method of finding greatest common factor is called the ladder method. So I can pull out 3 as a factor of both 30 and 18. So 30 divided by 3 is 10. 18 divided by 3 is 6. And then I can pull out from 10 and 2, because I'm done with those ones, 10 and 2, a prime number that I can pull out of both of those is 2. 10 divided by 2 is 5. 6 divided by 2 is 3. So from here, I now have 5 and 3, which don't have any common factors except for 1, but that doesn't count. So my greatest common factor is the product of the factors I pulled out. 3 times 2 is 6. So the greatest common factor of 30 and 18 is 6. So that's going to be the factor I pull out. When I had 30 plus 18, If I divide 6 out of both of them, then I can have 6 on the outside, and 6 divided by 30 is 5, and 6 divided by 18 is 3. Now the ladder method gives us those numbers that go on the inside. This ladder method is a quick way of grabbing all of the necessary parts to rewrite this distributed version into the less distributed version, because these are both the same thing. So let's try that now with number 2, which was 45 and 25. And I can pull out a common factor of 5. 45 divided by 5 is 9. And 25 divided by 5 is 5. I cannot divide any more numbers out of 9 and 5, except for 1, but it doesn't count. So this is going to be my factor that I pulled out. And 45 divided by 5 is 9. 25 divided by 5 is 5, which was the original expression that we started with. So by doing this ladder method to find the greatest common factor, the last row at the bottom will give you the numbers that go inside the parentheses. We are going to continue practicing this, and it's okay if it doesn't feel 100% good yet, but we're just going to keep practicing these steps for using the greatest common factor to show distributive property. And distributive property is showing the two different ways to show an expression.